Hi, it's James from Enso. Today I'm looking at day 6 of Advent of Code. I've already copied the example and a link to my dataset in, as well as the text of the puzzle. In this case, we need to compute for each column the operation at the bottom, aggregating all the results. Let's start by parsing the data. I'm going to start by converting this into a set of lines, turn it into a table, and then I will parse it to columns. And I'm going to use tokenize rather than parse because I want to break it into multiple sections. Find a regular expression there. I want to the value, move the expression on /s plus. So anything that isn't white space will become a column. And let's see what we end up with. That looks promising. Now what I'm going to do is I'm going to drop the last row. Parse the values. And now we have all the numbers. Then I'm going to now transpose the data. We'll call it column. So we now have a set of columns, and the values that were in them. Before we do that, do I need a row number? I don't think I need a row number for this, so that's fine. I'm going to copy this over here, and instead of dropping the last one, I'm going to take the last row. And again, I'm going to transpose this. Then we'll call it column, but this time I will call it operation. And that now gives us the operations we want to perform on it. Let's join it back to the original data. Have a look at what we've got. We now have the column, the value, and the operation. So the easy set are the ones where the operation is equal to plus. We can just do an aggregate. We can write column and aggregating the sum of the value. And we'll now do filter where the operation is times. For the product, I'm going to do the aggregate over, again, grouped by column, but this time I'm going to do the sum of an expression, and I'm going to put the log of the value. And then I'm going to set, let's call this total. And let's also rename the one over here total. And then in here, I'm going to do an expression. I'm going to round the exponent of total. And call that total, as we don't have a product aggregation at the moment. Then I'm going to union the two sets. And now I can do an aggregate of the sum and that's indeed the answer we expected for the example case. Let's turn it over to the real data set. See if anything goes wrong. And we have the answer for part 1. I'll pause the video here and move on to part 2. Okay, I've added part 2 and reset us back to the example. So for part 2, we need to look at the lines before the final line and effectively read the numbers vertically downwards. I'm going to use first of all, I'm going to change the way we parse it, and I'm going to start by looking at the last line and using this as a template to build a regular expression to line apart. Let's have a look at this line. So I want to split this line around each of the stars or the pluses and then break it into a sequence. I can use tokenize to do that. Put in a pattern of either star and plus, followed by some white space. I'm then going to mark that as the group I'm interested in, and then I'm going to say that after this group there must be either a space or the end of the string. And let's see what we get out of there. So now I've got the length of each column with a space following it. I can then my goal is to then turn that into a regular expression I can use. So I'm going to map over this list and get the length of each of those. Then I'm going to map over the length and turn those into a regular expression. So I'm going to write a simple lambda, and this lambda is going to say that I want to match dot plus the length so many times. And then followed by an extra character or the end of the string. And again, I don't want to capture that group. So this has turned those different ones into a regular expression. Does that look correct? These are all 3-digit longs, though I know in the input file some of them are 4 characters long, so this should be flexible enough to cope with that. I'm then going to join this together into a single expression. So let's have a look what we've got. So now I have one regular expression that will capture each numeric block. And now I'm going to feed that back into the table that we produced of all the other rows and see what we get. So let's take that table. We'll remove the last row, because the last row contains the various type multiplication and addition indicators. And then I'm going to use a parse to columns, which takes a regular expression and produces a set of columns. We're going to parse the value on the pattern. And let's see, and then I'm going to tell it to not parse the numbers because I need to work with them as unadjusted text values. I now have the sets of numbers. They look good with the spaces in the right place, so we can work out how to turn them into vertical numbers. Let's again transpose it. We'll call the first one column, same as we did before. And now I'm going to generate rows over an integer range from 0 to the length of the value. And we're going to call this one index. And then we're going to use that to get a character out. So let's use an expression, text mid, value, index 1, we'll call char. Let's have a quick look and make sure this looks good. We just look at value 1. We've got the result we're looking for is going to be to parse these numbers, so 1, 24, and 356. So the next step is now to group by column, index, and concatenate the char to produce a new value. Do that using aggregate. column index concatenate the jar, and we'll call that one value. Have a look at 1, 2, 4, perfect. And then we can do a parse on the value, do an integer. Again, look, we've now got that. We'll remove the index column, and we can then feed that back into the drawing that we had previously. Recalculate the whole workflow, and this should hopefully produce the answer of 3263827, which it does. And so the final step is just to turn it over to the real data set and let it evaluate through. And that's the answer, part 2.